fried fish sandwiches. All right, guys.
Still fried fish sandwiches?
I don't know.
Can I check my
Apparently they changed
phone to see what it is?
Go for it, Subway. It's like
The menu says fish.
All right, everybody. We are recording. Or Brendan.
See if they change it on
Hello. And then go ahead and go over.
What's up, Brendan?
All right. First thing I want to do, I want to make sure we're all on the same. First thing I want to do is hand out these sheets on conic sections for you all. Okay. These are all basically I took all the stuff about conic sections and I typed it up into a nice handy sheet for you all, so you don't have to keep flipping around looking for it in random locations.
You're going to give one to Brendan.
Okay.
Yeah. You got to give one to Brendan.
Thank you.
Right, give one to Brendan.
This is very easy.
Okay.
What's up, man?
All right. Here we go. I'll send it to you over email. Okay. Anyway, so this just goes through. It's got all the equations on it for conic sections in one handy spot, so we're not having to like flip through the book and search for them all. Okay. It also has examples to the side of what these things would look like based off of their things. Okay. So it's got it for the circle, the ellipse, the parabola, and a new one that we're going to learn today. I think I mentioned it yesterday, but we'll go over it again today. The hyperbola. Okay? Hyperbola. All right? Okay, everybody. So, what we're going to do first is just make sure we're on the same page as with ellipses. Okay? Kind of go over exactly how to figure out all the pieces of an ellipse. Okay? From an example problems. This is like the homework from last night. Okay? On page 677. So we'll look at 7, 9, and 11 from okay. Example ellipse problems. Okay. So this is on page 677. We're looking at numbers 7, 9, and 11. Okay. What we want to do here is we want to find the center, vertices, foci, and eccentricity of the ellipses. Of the ellipse that we're going to do, okay? So we'll start off with number 7, okay? Number 7, we've got the ellipse x squared over 64 plus y squared over 9 equals 1, okay? Standard ellipse stuff, all right? Easiest thing to find should be the center. What's the center going to be?
0, 0.
Center is 0, 0. Okay? Next thing, vertices. Now, vertices are going to be determined by your axes, okay? With the appropriate one going in the appropriate, with the major axis going in the being one, and then the minor axis being the other. Okay, so what are my axes going to be? What's my major axis going to be? 8. Okay. The major axis is 8. The minor is what? 3. Now, how that relates to vertices, okay, is basically you're going to add the major axis to the x equation because the x vertex is along the major axis, okay, and you're going to add, you'll add 3 to the minor axis, okay, or sorry, you add 3 to the y coordinates to get the minor axis, okay. So, I'm going to have 4 vertices. The first one will be at 8, 0. The next one will be at minus 8, 0. Okay? And then the two that correspond to the minor axis would be 0, 3, and 0, minus 3. Okay? And that's all the, where all the vertices would be. Everyone see how that works? Okay? Basically, x coordinate plus major, x coordinate minus major, y coordinate plus minor, y coordinate minus minor.
Those are the vertices right there.
Those would be all the vertices, all 4 of them. Okay.
This would be a horizontal ellipses, right?
Yep. Again, because 64, the big number is underneath x squared, so that's the major axis we're dealing with. Okay? Alright, that was easy enough to find. Next is the foci. Okay? The foci, first we need to figure out what the number c is for our focuses. I'm just going to say focuses. I hate saying foci. Sounds like we're cursing. Okay? The focuses. Okay? Yeah. Yes. But basically, it's going to be, c is going to be, remember, equal to the square root of 64 minus 9. Okay? That's the focus number. Okay? So that's going to be square root of 55. And the focuses always lie on the major axis. So we're going to do the same thing we did to find the vertices, but use this focus number instead. Okay? So but this time we only do it for the major axis. So it'll be basically x plus focus and x minus focus. So my focuses will be at 0 plus root 55, so root 55, 0, and 0 minus root 55, so it would be negative root 55.
I thought it was the other way around for a horizontal ellipse.
Huh?
I thought it was the other way around for a horizontal ellipse.
For horizontal ellipse, no.
Oh, on the sheet it says
Of
h plus or minus c, k.
right. So h is 0. That's the x one, right?
Yeah.
So I'm adding my focus.
Oh, sorry. I was looking at the comma wrong on that one.
Sorry. Yeah. I guess it did kind of run a little together there.
Sorry.
Okay. But yeah, that's okay. Got it now.
Yeah.
All right. Good. So that's basically the foci, focuses. Okay. Last thing we need is eccentricity. That one's easy to figure out. The eccentricity is just the focus number c divided by the major axis. So root 55 over 8. And in this case, it's approximately equal to 0.925. Okay. Actually, I think it's 0.927. Excuse me. Okay. Everyone see how that works?
So root 55 over
8.
8.
92.7. Less than rock ethic. There. But that's the, those are all your equations, okay? That's how you find all the pieces. Any questions there? Alright, if I wanted to graph this, by the way, I can then just go through and just plug all these points in and connect the dots, basically, and get the nice graph of it. Alright. Alright, that's how this works. Let's take a look at another example. Let's do number 9. We'll skip number 11. We don't need to do number 11. It works the same way as number 9. But number 9 will give you all the ideas here, okay? So, next example, okay, same thing, so same directions. This time we've got our ellipse. It's going to be x minus 4 squared over 16 plus y plus 1 squared over 25 equals 1. Okay? So first, the center, where's that going to be?
4, negative 1.
4, negative 1. Okay? Major axis? I think we did that.
5, 4.
Have the same center.
5. Minor?
4.
4. Okay? So, my vertices are going to be, the ones going with the major axis will be 4, then negative 1 plus 5, so 4, 4, and then 4, negative 1 minus 5, so minus 6. Because this time the major axis is in the y direction. Okay? And then we do the same thing to find the vertices on the minor axis, except this time we're adding 4, we're going to add the 4 to x. So it should be 8, negative 1, and 0, negative 1. So those would be my 4 vertices. Any questions on how that works? Okay? If it helps, you could label this one as the y, and this one as the x. Okay? Y-axis y-axis, x-axis, okay? Because that's basically what goes on here, okay? All right, now the rest of this just happens the same way as before, okay? We go ahead and we figure out the focus number. That's going to be C. That's going to be equal to the square root of 25 minus 16, which is root 9, which is also written as 3. So then my two focuses, okay, will be the y number plus 3 and the y number minus 3. So they should happen at 4, 2, and 4 minus 4 will be where my two focuses are. Okay. Any questions there? All right. Lastly, eccentricity. That's going to be focus number divided by major axis. So this will be 3 over 5, which is equal to 0.6. Okay? And those are all the pieces we need for this thing. All right? Any questions on how I found any of that information? Okay. Okay. A lot of the difficulty of this is just making sure we keep everything straight.
Yeah.
Really, tomorrow we're going to spend a review because Friday's our test. Okay. Or I guess, wait, Friday's our test. Tomorrow, I guess tomorrow's Wednesday. So we can spend more time on this tomorrow if you want to, going over everything. Okay. But I was going to start moving ahead. Okay. To stuff. Basically, after hyperbola, there's no new information on the test.
Wait, so after this?
There's hyperbola, and then after hyperbola, that's it. We're done with the next step. Okay? Alright. Rhodes, you got a question?
Kind of. So, is major axis always, like, horizontal?
No. Major axis is going to go, basically, it's always determined by whatever number is underneath, or whatever the bigger of these two numbers are. So here, the major axis is underneath y, so it's actually a vertical axis, okay? On the previous problem, the major axis, the bigger number was under x, so that makes it horizontal, okay? And that's how you can tell the difference of whether I have a vertical ellipse or a horizontal ellipse. You just look for that major axis number, okay? Better?
Yeah.
All right, good. Any questions on how any of this works? Huh? No? Alright. Then we should be good on that front now. Okay. The next thing we're going to look at now is we're going to move right ahead, and we're going to talk about hyperbolas. That's our next shape. Okay? That's the last conic section we have. So it's going to be on the reverse of this. It's the bottom one. Okay? Bottom one in reverse. Okay? So hyperbolas. Okay. Now, a hyperbola, okay, basically it's actually a set of two curves, okay, as opposed to one. So they look very, very much like they look very similar to a parabola, okay, but they're actually not. Because one, a parabola would just be a single curve. This would always be two. The other thing about hyperbolas as well is that they're not, they're less curvy than a parabola. So if you put a parabola and a hyperbola next to each other, the parabola would be a very happy, kind of nice U shape. The hyperbola would be kind of this very long, lazy curve. Okay, it almost looks like the edge of a really big circle, if you will. Okay, it doesn't have a lot of change in the curve. Okay, so to give you an idea, the hyperbola, let me go ahead and draw them. Okay. Okay. This would be a set of horizontal ones. Okay. And over here, these would be vertical